right? Down here, I'm going to pick a point over here. And this point represents the center of curvature. Okay, the point that I pick is known as the center of curvature. And I'm going to sketch a line in green. And this represents the centroid. Okay, represents the centroid. And I will draw our transformation just for you to recall. So this is our transformation. This is X, this is Y, and this is rotation about Z. And we are aware that we have an applied force coming down of the center T. Okay. So due to the fact on how the structure has been deformed, we are going to sketch the moment vector. Okay. So the moment is about Z-axis. Okay. So I'll draw it again over here. The moment is about Z-axis. And why is it at that direction, right? So if you physically were to bend the structure, you have to rotate your hands. If you can see the video of me now, your moment has to be curving in, yes, for the structure to deform that way. Let me see. Do I have a ruler with me? I think I do. I just need to find it. Right. So I want you to focus on the video now, right? Or let me tell you what, if I stop sharing, can you all see my face now? Yes or no? Can someone say yes?
Yes.
Okay, so when I curve my ruler this way, right, in a smiling face configuration, you look at my fingers. Okay, you look at my fingers. My fingers have to like go around this way. Yes or no? Can you all see that motion? Okay, can you, right? You can see that motion. So that is why when I sketch, or when we sketch the, I do apologize. When we sketch, I hope now you see my one note, yes?
Yep, we're back.
Yes.
Okay, thank you. Okay, so that is why we draw the moment in that direction. Okay, now why is it, then you ask me, Eugene, then why is it moment about Z-axis? Okay, so I want you to focus on the curvature now. Okay, so you can see the curvature that I'm highlighting yellow, and the curvature of the rotation about Z, right? The curvature is in the same orientation, yes or no? Right? So for that case, that is rotation about Z. Okay, about the Z-axis. Okay, so now with this, we can see that I'm going to call out 2 points. Okay, so we have our point C over here. I'm going to call out 2 points, or label 2 points, and the point up here is my point C alpha, and the one below is my point C beta. Okay, I'm going to call point C alpha and point C beta. Right? Because of the if we were to look at the centroid, right? If you were to look at the circumference of the centroid, where C alpha is located at this point over here, right? Which I'm coloring it in blue. We realize that the circumference is smaller than what we see on the centroid. Yes, the curvature, okay, the circumference of the curvature is smaller. So from here, we are aware, okay, we are made aware that this is under compression. Okay, and where I'm going to highlight in yellow the outer circumference, we know that the circumference is longer than that on the centroid. Okay, so with that, we know that it's going to be under tension. or tensile. Okay, we know that. Okay,
I'm sorry, could you repeat that last part again?
so we know that where I highlight in yellow, the circumference, the outer circumference in yellow, right? The distance is longer than the center, or the circumference is longer than the centroid, yes? Right? So with that, we know that on the outer circumference, okay, it is under tensile. Does that make sense to you?
Okay, thank you.
You're okay, Matthew. You're okay. Okay. So now, the next thing I want you all to focus on is to focus on the term I mentioned, which is the center of curvature. Okay, focus now. Okay. So now we are going to see, we are going to look at the distance. Okay. So when the distance is pointing towards the center of curvature, your y is positive. Okay, relative from the center. From the centroid, okay, from the centroid, when it's pointing away, the distance is going away from the center of curvature. Y is what? Negative. Okay, I want you to see that. So now let's look at the general formula. Okay, let's look at the general formula. Where it states that stress X, okay, so normal stress, and later on I'll explain to you what do we mean by normal stress in the X direction. This will be equal to minus mz over izz multiplied by y. Okay, so I want to focus on point C alpha. Okay, so if we were to find the stress, the normal stress, or find the normal stress in the X direction of point C alpha, okay, point C alpha, we know that y is going to be what? Positive. Right? Why y is positive? Because at point C alpha, okay, at point C alpha, relative from the centroid, right? Y is what? Positive. It's pointing towards the center of curvature. So when that is the case, when we just apply the formula, okay, we get stress X at point C alpha is equal to minus mz over izz multiplied by positive y. Okay, multiplied by positive y. So what you see over here, this formula will be equal to minus mz over izz multiplied by y. So the minus over here that you see indicate that is under what? Is under compression. Okay. So I'll do another one. Now we are going to find stress X of C beta, right? Point C beta. And now we know Y is equal to what? Negative. Why is it equal to negative? Because relative from the centroid, right? Point C beta is pointing away from the center of curvature, right? So that's why y is negative. So when that's the case, stress X of point C beta, okay, point C beta will be equal to minus mz over izz multiplied by negative y now. Okay, so negative multiplied by negative, it becomes what? Positive. So this is in tensile. Okay. Now, this course, I have a better way of doing this. Okay. So what do I mean better? If you cannot remember this formula that I'm going to highlight in a box now, if you forget that there's a minus sign, don't panic. What do I mean by don't panic? Now I want to draw your attention to the moment vector. So this is our moment vector. Okay, that is our moment vector. So by looking at the moment vector, the head of the moment vector is always under what? Compression. The tail end of the moment vector is always under tensile. Right? You can see that, and that's true. Okay, if you forget about the formula, it's fine. Okay, all you need to know is how to draw the moment vector based on the deformation, and you can see the head of the moment vector is always under compression, the tail end is under tensile. Okay, let me give you another quick example, okay, to prove the hypothesis. Okay, now what if now our deformation pattern is this way now? Okay, now this is our deformation pattern. Okay, this is our deformation pattern now. Okay, so I'm going to again draw our centroid. This is our centroid. Okay, so over here. Okay, and then at point C, so this is still our point C. I'm not going to change anything. I'm still going to call this point C alpha. Now this is our point C beta. Okay. So we know in order to have the deformation pattern looking like this, we know that moment about Z has to be acting in this direction now. Right? And then we are also aware the head of the moment vector is in compression. The tail is in what? Tensile. Okay. That's all you need to remember. Okay. Now, I'm going to do the old-fashioned way now. Okay, I'm going to do the old-fashioned way. So the old-fashioned way dictates that we need to know where the center of curvature. Okay, so this is our center of curvature. So this is method number 2. Okay. Method number 1 is just by looking at the moment vector. Method number 2 is you have to identify the center of curvature. Okay. From the centroid, when it's pointing towards the center of curvature, y is positive. When it's pointing away from the centroid, okay, from the centroid away from the center of curvature, y is negative. Okay, so now when we apply the formula, okay, so when we apply the formula, we are going to now find, okay, we're going to find stress x, and I'm still going to do the same. We're going to find C alpha. Okay, so we know for this case y is equal to negative. Why is negative? Because it's pointing away from the, I'll write down here, why is it negative? Because it's going away or from the centroid. Pointing away from the center of curvature. Okay. So that's why it's negative. So when that's the case, we have stress X, okay, C alpha